Describe what is seen when chlorine water is added to potassium bromide solution and the mixture is shaken. Okay, so what you'd see is a colour change. So what's happening here is chlorine is more reactive than bromine. So chlorine will basically displace bromine from the compound and replace it and bond with potassium. Because chlorine is more reactive than bromine. When the bromine is liberated, when it's freed up, because bromine, it's in its own state without being bonded, its natural property is to be of an orange, reddish-orange colour, you'll see the liquid turn orange during this displacement reaction. So your answer would be, it will go from colourless to orange. Only describing, you don't have to explain anything. Next, chlorine reacts with potassium bromide to form potassium chloride and bromine. In this reaction, chlorine forms chloride ions. In this reaction, chlorine has been reduced. Explain using the equation how you know that chlorine has been reduced. So firstly, what does reduction mean? Well, if you think of oil rig, oxidation is loss, reduction is gain. What we're saying reduced is gaining an electron. So that's what I mean by gain. Okay, so loss of electron or gaining an electron. So what it means is chlorine must have gained an electron in this process. So explain using the equation how you know that chlorine has been reduced. So chlorine is reacted with potassium. So potassium has 1 electron on its outer shell and chlorine has 7. So 1 electron has been transferred from chlorine to from potassium to chlorine to give it a full outer shell. So that's why it's been reduced. It's gained an electron from potassium, and that ends up with a full outer shell for potassium, the shell that's underneath this outer shell. So it's now 8 here, and this is an ionic bonding diagram, by the way. And here, chlorine has gained that 1 electron from potassium. Whenever you draw these, make sure that they always have a full outer shell. It's important because that's what happens when ions form. They gain a full outer shell. And this has a positive charge because it's lost a negative electron. This has a negative charge because it's gained a negative electron. So you'd say chlorine gas or chlorine gains electrons or gains electrons to form chloride ions. So that's all you have to say. How you know that chlorine has been reduced, because it's gained electrons to become an ion. This is a chloride ion here. Write the half equation for the formation of bromine from bromide ions. So we know bromine is Br2, and we know that bromine is a halogen, which means it has 7 electrons on its outer shell. To become a bromide ion, to complete its outer shell, it needs 1 more electron, which it will gain from an alkali metal in this case, or another element. So that's what it will gain. So we're saying here in this question how this is formed from bromide ions, right? So if we have Br2, we must have had 2 bromine or bromide ions to form them. So this is a Br minus and this is a Br minus. So the starting point here will be 2 Br minus producing a bromine molecule. So what we're producing here is this Br2. But in doing so, if we're reversing this process to form bromide ions, obviously we had to gain 2 electrons, 1 for each atom. So to reverse it, we'll have to remove these electrons, so we'll end up with 2 electrons. Okay, so this is the half equation. 2 Br minus produces Br2 plus the 2 electrons they give up to form the atoms again, which then form the molecule. Aluminium reacts with chlorine to form aluminium chloride. Write the balanced equation for this reaction. Okay, so firstly you need to know that chlorine forms a diatomic molecule, so chlorine will always be Cl2 in a reaction, and aluminium chloride, the halogens always form trichlorides, tribromides, so when they react with aluminium they always form the name of the halogen with a 3 at the end. So that's what it would look like. I don't think it tells you that there. It doesn't say trichloride, but you need to know that. So it's quite tricky if you don't know that, but let's assume for now that you do. Now you just need to balance it. So that's actually the hard part. Then you just have to balance it. So do what I do. Draw the line down the product line here and write the chemicals here on each side. So we have aluminium and chlorine on this side, and therefore aluminium and chlorine on this side. We start off with 1 here and 2 here. and 1 here, and 3 here. So we can see we're down with chlorine on this side. Remember, we can only put elements here, here, and here. So we're down with chlorine on this side. So let's up chlorine by adding another one. So default we're at 1. I'm going to put 2 there. Let's change that to, now we have 4 chlorine here. So now we're down on this side. So I'm going to put with default 1. So I'm going to up this by putting 2 here. So if I put 2 here, we now have 6 on this side, and we have 2 aluminium on this side. So now let's change this. I need to up this again. So 4 is down on 6. So let's put 3 here. And that now becomes 6. 3 times 2 is 6. So now these are balanced. But the aluminiums are now out of whack. So we've got 2 here, 1 here. So if I just put a 2 there, then this becomes 2 and we're balanced. So if we go back, 2, 3, 2 is what we're looking for. And don't worry about making a mess on the paper. Do that. I mean, if you need a balanced equation, use the available space to do it. Okay, next. A solid ionic compound is dissolved in water to form a solution. Describe a simple experiment to show that charged particles are present in the solution. So charged is the clue. Charged particles can conduct electricity. So what you could do is you could just connect a power supply or a battery to a circuit with electrodes, dip the electrodes in the solution and just have a bulb. If it conducts electricity, the bulb will glow. The power supply is needed to push the electrons around, otherwise there's no push, and if they can't move, they won't light this up. But the fact there's charged particles in there shows it will glow. So insert electrodes, connect to power supply, and bulb will light up. Simple as that. Remember, this is one of the most popular questions about to do with ionic compounds, the ability that they can conduct electricity when dissolved or when melted. Because in an ionic compound, you have charged particles fixed in a lattice. Now, in a solid state, these particles can't move, they can't conduct electric current. But when melted or dissolved, they are free to move, these ions are free to move, and they can conduct electric current. So look out for questions like that, where they say, why can't ionic compounds conduct electricity when solid, but they can when dissolved or